So now we're going to look at the Pythagorean identity, which, as you can guess, comes from the Pythagorean theorem. So this is our picture that we've used to generate a lot of things this unit. Here we have the unit circle. We have a triangle drawn with an angle in standard position. So we're going to follow these steps. Label the point on the circle xy. I already naturally labeled the angle theta. And label the base and height on the triangle in terms of x and y. So we know that the y value is the height and the x value is the base. And then we know from the unit circle that the radius is 1. So from this little triangle here, we're just going to write the Pythagorean theorem, what that would be for that triangle. So that would be x squared plus y squared equals 1, which is also the equation of that circle we know, right? X squared plus y squared equals 1. So hopefully that kind of makes a little more sense where equations of circles come from. They can get more complex if the center is somewhere else or if the radius isn't 1, but it's basically just a Pythagorean theorem. So we know from our study of the unit circle that any point on the unit circle is cosine theta, sine theta. And that's because from this angle, cosine adjacent over hypotenuse is x, and sine opposite over hypotenuse is the y value. So here the x is cosine theta and the y is sine theta. Now, based on this, we have x squared plus y squared equals 1. Now we can also substitute cosine and sine in for x and y, and it's also true that cosine squared theta plus sine squared theta equals 1. So I'm just plugging these in. So this is an identity, okay? That's also always true. If I have an angle and I know it's cosine and sine, if I square them both and add them together, they will always equal 1, okay? Now, that's the Pythagorean identity. I'm going to write it over here. Usually, we write the sine squared theta first. That's just the way you'll hear it said. Okay, it doesn't matter, just commutative property. But that is your basic Pythagorean identity. Now we can do other things with that identity. So we could solve for sine squared theta. So if I took this equation, I'm going to write it here. And I wanted to get a new identity that was equal to sine squared, I could subtract the cosine squared and move it to the other side. So when I solve for sine squared theta, I get sine squared theta equals 1 minus cosine squared theta. Using the same type of reasoning, instead of moving over cosine, I could have moved over sine. So if I solve for cosine, or cosine squared theta, that's equal to 1 minus sine squared theta. So these are just different ways to write your basic Pythagorean identity. Basically, originally we have it solved for 1, but we could solve for sine squared theta or cosine squared theta. So we're going to write that in this chart down here. Okay, so our basic Pythagorean identity is sine squared theta plus cosine squared theta equals 1. Underneath that, other ways to write that identity are sine squared theta is equal to 1 minus cosine squared theta, or cosine squared theta equals 1 minus sine squared theta. So what are these second and third Pythagorean identities? I'm going to change these to thetas here, not x's, because we were writing things with theta. Okay. So basically, we can further transform it. If we take the basic Pythagorean identity, and I'm going to write that at the top of both of these spots, we can either divide it by cosine squared theta or sine squared theta. So I'm writing this purposely up towards the top so I have room to do the division. Okay? So if I take my basic Pythagorean identity, here in blue, and I divide both sides by cosine squared theta, I get another true statement, another identity. It's called the second Pythagorean identity. And really knowing the difference between the second and third, like which one's called which, is not important. But here it is. So sine squared divided by cosine squared is tangent squared theta. Cosine squared divided by itself is 1. 1 divided by cosine squared is secant squared theta. So this is the second Pythagorean identity, okay? Just as true as the first one. It's not the one we usually start with or know the best, but that is another true identity. Now, just like the first Pythagorean, basic Pythagorean identity can be solved for one of the two things on the left side, this same thing can happen with this one. So if I solved for tangent squared theta, right, and I moved, that would mean I would have to move over this 1. That would give me secant squared theta minus 1. If I solved for the 1, I would get 1 equals, and that would be secant squared theta. I'd have to move over the tangent squared theta, so I would get secant squared theta minus tangent squared theta. Okay, so those are two other ways to write the second Pythagorean identity. Moving on to the third one, the other option will be to divide by sine squared theta. So sine squared theta divided by itself, I'm actually going to write it over here, just to kind of have it written correctly. These should kind of be separate, dividing both sides by the same thing. Sine squared theta divided by itself is 1. Cosine squared theta over sine squared theta would be cotangent squared theta. Oops, wrong spot. Sorry about that if you're writing with pen. So this is 1 plus cotangent squared theta. 1 over sine squared theta is cosecant squared theta. So this is your third Pythagorean identity, and now we'll just write it in those two other ways. So as I said, the order of this stuff doesn't really matter. I'm going to solve for cotangent squared first, just to kind of have it be in the same structure as this one, but it doesn't really matter. So that means I have to move over the 1, so that's cosecant squared theta minus 1. Down here for this one, I'm going to solve for 1, which means I have to move over the cotangent squared theta, so I have cosecant squared theta minus cotangent squared theta. So this looks like a whole lot, but the basic idea is you understand that this basic Pythagorean identity comes from the unit circle, okay? And then the rest of them are just, we can divide by different things, we can move things to other sides of equations, and then you have these other 8 different ways to write it. So there's a flow chart on the next page, and it kind of just shows you, we're going to rewrite the different values in here, okay? And I am going to write them pretty quickly. And actually, you know what? I'm going to leave this up to you guys to copy them over, okay? So I'm going to do the last part on the video, but I think the process of getting them over to the flowchart kind of helps. So this basic one is going to go right here. These are the 2 solved ones. This is the second one, right here. And then the 2 ways to solve it. And the third one will go on the right side of the flowchart, and then the 2 ways to solve it. So we're going to come down, sorry, wrong direction, to answer these questions. In your packet, this problem is incorrect. Okay, I forget what it says. I think it might be a minus sign or something, but that should be 1 plus cotangent squared theta. So these are super simple identities with the Pythagorean identity. For example, if I could substitute something for sine squared theta plus cosine squared theta, what could I put in its place? Well, in the place of this, from my very basic first Pythagorean identity, this is just equal to 1, okay? So that's my answer. Oops, not erasing it, I was just trying to circle the actual answer, not the question. From that identity, sine squared theta plus cosine squared theta equals 1. This 1 minus sine squared theta would equal cosine squared theta, right? So this could be substituted for 1 minus sine squared theta, okay? I'm going to look back at the previous page since we don't have the flowchart filled out, and you kind of just get a feel for it, even if you don't perfectly have all pieces of that memorized. Well, if you kind of get that idea, it's a square, there's a 1 there. I think that goes with my my third Pythagorean identity, right? So if I look back at my chart, 1 plus cotangent squared theta equals cosecant squared theta. So in the place of this, I can write this as a single trig function, cosecant squared theta. Okay. Lastly, we have secant squared theta minus 1. So that reminds me of my second Pythagorean identity, but there's a subtraction. So I'm just going to look back at the chart. I don't expect you guys, it's really nice if you have this memorized and kind of can get these in your head pretty well, but you can look back at these. So tangent squared theta equals secant squared theta minus 1. So secant squared theta minus 1, we could substitute tangent squared theta. And a lot of the end of this unit is just kind of getting you ready if you're going to pre-calc, and just having seen this stuff and having thought through it once will help you when you do it a little more extensively in that class.